Had a patient who had a tumor so large that half of his jaw needs to be removed. So we helped the surgeon plan his case so precisely that after the surgery, his left and right face are still perfectly symmetrical. So these results are what push us to go forward. We use it as our gasoline to go faster every time.
Welcome, MedTech Gurus. Today, as I mentioned in the introduction, we're joined by an exciting innovator, Vikram Ahuja, co-founder and CEO of OsseoLabs, a MedTech company that's using AI and 3D printing to eliminate the guesswork from orthopedic and maxillofacial surgery. Vikram and his team are transforming how surgeries are planned and performed, moving from time-consuming intraoperative improvisation to streamlined pre-surgical precision. Traditionally, surgeons rely on 2D imaging and off-the-shelf implants, often spending hours custom-fitting titanium plates during surgery. OsseoLabs flips this outdated model by generating custom biocompatible implants based on the patient's own biomechanical data before the patient enters the OR. The result? Shorter procedures, fewer complications, and no secondary surgeries. With over 40 hospital partnerships and 170 plus surgeries completed in Southeast Asia, Vikram is here to share how his technology is reshaping care and why the U.S. healthcare system should take note. Hey, Vicky, are you ready to be our guru today?
Yes, thank you, Tom. It's great to be here.
Yes, and I should mention you like to go by the name Vicky. That's your nickname, right?
Yes, that's correct.
That's awesome. So, Vicky, first of all, let's start out. Tell us something fun or interesting about yourself or your family so we can get to know you a little better.
Yes, so I was born and raised in Thailand in a family of doctors. I am half Indian, half Thai. So that's pretty common for Indians in Southeast Asia. Many of us are doctors. My father is a doctor. My uncles are also a doctor. I have 15 cousins and around half are also doctor. We used to have a family business running a hospital in Thailand. I always thought that one day I would be a doctor too, but as it turns out, when I'm 15, I learned that I'm colorblind. And in Thailand, if you are colorblind, you are not allowed to enter a medical school. So my dream was out the window. And so I studied financial economics instead. I love economics. I love the concepts, but the PhD study took the fun out of it. And therefore, after I finished my PhD, I decided to make a change. I feel that I need a change. I returned to Thailand to start a company doing high-performance EV scooters. It was acquired in 2021, and then I started OsseoLabs. It feels a bit like coming home to be doing something medical related again. And my friends still joke that I make EV scooters so people can break their bones and then I make implants to fix them, which is not the plan, of course. What I love the most is to see new innovations to actually change the world. In the EV years, we were the first company to have an EV scooter homologated in Thailand. We developed almost every single part in-house using engineering knowledge. We pushed the boundaries and helped change the norm and reduce air pollution and traffic. And at the same time, making sure that our scooters are still fun to ride on, right? With OsseoLabs, we're doing the exact same thing. We use our engineer knowledge, technical knowledge to transform surgery. We're also one of the first in Southeast Asia to make personalized implants using 3D printing. We help the surgeons to treat the patients in a much better way using our engineering knowledge. And as a founder, it's good to be the one who actually making it, pushing it, and watching the changes happening. It feels so good every time we talk to the surgeons or the patients 6 months post-op and learn how much we transform people's lives. There's no better feeling than that. And this exact same feeling is what keeps us pushing me and pushing our team to go further and make better solutions that benefits the patients worldwide.
Yeah, that's fascinating. We'll get in more into the company, but just coming from a family of doctors like that, it sounds like in a way you're kind of coming back and interacting with the family with your medical device career, right?
Yes. When I have a conversation with my father and my sister, they are all doctors, right? And they always have this conversation that I cannot be a part of. Now I can join them in their conversation, which feels nice.
Yeah, I love that. So Vicky, first of all, you and your team are really solving what I consider a major challenge in surgery, right? And it doesn't often make the headlines. What first drew your attention to this issue of intraoperative guesswork and the inefficiencies around 2D imaging and generic implants? Can you provide us a little insight there?
That's a fantastic question, Tom. So this goes back to even before OsseoLabs was formed, right? So at the time, we were a team of engineers working on 3D printing projects in a university lab. My co-founder was helping Airbus to make 3D printed components for aircraft, which can take complex shapes and therefore it needs to be 3D printed. In EV motorcycles too, we use some 3D printed components in the battery pack to manage heat and to reduce the size and the weight of the battery pack. And one day we got a call from a small group of surgeons in Thailand who saw the use cases of 3D printed implants from a conference somewhere. And they have some very cool ideas of how to improve them. So they asked if we can help them on the technical side. So what we learned throughout the process from the surgeons, right, was what we found quite surprising. And it was very obvious that 3D printing can help a lot. So I can give you one example, right? Say a patient has a tumor in the jaw, which needs to be cut out. There's a procedure where you need to take the bones from your leg to reconstruct the bone in your jaw, right? The entire surgery can take 10 to 18 hours. It's very long because the surgeons have to measure the length of the bone that will be taken from the leg and then put them in the jaw and hope that they fit perfectly, which most of the time it's not always the case, right? And once the sizes of the bones are all clear, they still have to deal with the fixation plates, which are the titanium plates to fix the pieces of the bone and construct a new jaw. So these plates are normally the plates that they use comes in fixed sizes and shapes. So in the surgery room, the surgeons will have to bend the plate by hand to fit, which also takes a lot of time. And we rely on the surgeons to be very, very precise, right? It got me thinking, we live in a world where cars are customized, shoes are sometimes also customized, right? Even skincare products nowadays are also customized and personalized. So why are we still using one size fits all type of implants in surgery? We realized that surgeons, they did not lack skill, right? They lack better tools. So we feel that we needed to give them personalized implants and surgical instruments as their weapons, and they should be able to fit perfectly the very first time. And with our knowledge in 3D printing, 3D planning, and AI, we can give them what they need, make it very easy to use, and also at the same time, make it cost effective. And that's where the idea for OsseoLabs started.
Yeah, that makes total sense. And it kind of leads into my next question a little bit. But, I'm thinking, first of all, when you think about taking a tumor, each and every time there's tissue at the margin, you're not quite sure, you're cutting more than maybe you thought. So there's a lot of things that are going on in the OR when they really get in there to see what the affected tissue or bone structure is happening, right? So with I think you've got a unique approach to the pre-surgical planning part. Maybe you can walk us through how that AI platform works, from that implant to custom implant delivery. Can you give us a high level overview of that?
Yes. So to understand the software side of things, I think it's also important to understand how the hardware works. So when we talk to the audience, we always say that we are the company that provide personalized implants and surgical solutions. Right? It's not only implants; it's both the implants and the surgical solutions, mainly for complicated surgeries through the use of 3D printing, biomechanics, and AI. So here's how I usually like to explain what we do in a nutshell. Say to a 5-year-old, right? So imagine, you break your toy and you need a new piece to fix it. But this cannot just be any piece, right? It has to fit exactly the right way or the toy won't work. That's kind of what we do, but with people. Let's say you fall off your bike and break your leg, right? You go to a doctor, but sometimes the doctor, they don't have the perfect tool to fix it because everyone's body is different, right? So my company, OsseoLabs, we make custom-made parts called implants. They help doctors fix broken bones or missing body parts in the best possible way. We use 3D printing to create the hardware, create these parts. And it's not just any part. So each part is designed specifically to your body. And it's not just the parts that matter, right? It's also how the doctors prepare for the surgery as well. And this is where the AI comes in, right? So we built a tool called OsseoVisions that helps surgeons plan the surgeries before they enter the surgery room. It uses 3D design and AI to understand each patient's body and figure out the best way to operate. That saves doctors hours of work and helps them also to avoid mistakes. Everything starts with a CT scan, right? So the surgeon uploads the CT file to our secure platform. Then OsseoVision, our AI system, takes over. It auto segments the bones, map out the defects, simulate how the forces would act on different implant designs, which can be different for each area of the body and also how the implants are to function. Then with some input from the surgeons, right, combined with our AI work, we create a surgical plan and a fully personalized implants that fits perfectly to the patient's anatomy. That design is then sent to our 3D printing facility. And to be 3D printed, it's ISO 13485 certified facility. And then we ship to the hospital in approximately 3 to 10 days, depending on where the user is. We also include custom cutting guides, so the surgeons don't have to guess where to cut. And this minimizes the surgery time and also reduces the chance for any mistake in the surgery room. It's almost like surgery with GPS, right? Everything is planned, precise, and personalized. And the surgeons get the outcome they want faster and more efficiently.
Yeah, that's really fascinating. So, I'm going to take us back just a half a step here because, as you mentioned, you combine the AI in biomechanics and 3D printing, right? So, there's a lot of technology coming together here, and I'm just kind of curious what some of your biggest technical or clinical challenges that you had, and how did you overcome them to get to this point? I don't imagine that happened overnight.
Yes, it's been a very long journey, and everything was very hard in the beginning, and it gets easier over time. So on the technical side, right, I would say that putting each piece of the workflow together is most difficult because, as you can see, that we not only provide the hardware, we reinvent the entire workflow for the surgeons, right? Especially to achieve that at a price point and the user experience that is streamlined and easy for us to scale and also easy for the users to use. We know 3D printing is an innovation that can add a lot of value, but that's only the hardware side. Now, just to give you some context here, to get the hardware right, we also need engineers to design, right? Most of our engineers and most of the graduates coming out from the engineering schools, most of them are not specifically trained to design medical devices. So most of the time, we also have to train them up, and that's also not easy. And if we rely on manual design by the engineers, then cost will also not be appealing, right? Because these engineers are not cheap. So we knew right from the start that we need to use AI to speed things up and also to cost down. And with AI again, which is very new, right? Also new to most surgeons, we also need to build a workflow that's easy for the surgeons to use and also 100% effective. So there's no doubt from the users at all. Once the surgeons lose the trust, they will never come back, right? So on the clinical side, I would say the hardest part was to build trust with the users, especially the surgeons. The surgeons could not be sure. We have to understand them too, right? They cannot be sure that if our AI could be a better solution than what they always did manually, we had to prove it case by case and surgeon by surgeon. So we work very closely with top surgeons in top hospitals to build that trust. Sometimes new product development is also challenging, although I wouldn't say that it's as challenging as reinventing the workflow. In some specific cases, for example, 3D printing magnesium implants was also a big challenge that we went through. It took us over a year to get it right because magnesium as a material burns very easily, right? It's hard to control. But we knew the value magnesium can dissolve in the body, can biodegrade. So no removal surgery will be needed. We want that. And the patients also need that, right? There's a lot of value for the patients and for the healthcare system in general. I would say there's no textbook for what we do, but it's been a long and very challenging journey. We are always thankful for all the help from the surgeons we work with, and they have been very supportive. I'm sure there will be a lot more challenges to come, but we have a very good team. We have built a very good team right now to deal with any challenges that may come our way.
Yeah, that's very helpful, and it always kind of comes back to the people, right? And getting the high quality individuals involved with an organization.
Yes.
So Vicky, I mean, as mentioned, you've seen some real world success already, right? If I've got this right, 170 plus surgeries in Thailand. And I'm just kind of curious about what types of results you're seeing with that. If you've got anything that's quantifiable in terms of seeing operating times decrease or reduction in complication rates and patient outcomes, do you have any data like that you're starting to see for your solution?
Yes, the number of cases went up very fast. So just last month, we increased from 170 to more than 200 now. So
Oh wow.
that confirmed the traction of the and also the trust that the patients have with us. And the results have been very good, right? So on average, we can cut the surgery time by 50% or more because of the implants that pre-designed and fit perfectly, and also because of the surgical instruments, for example, the cutting guides that help the surgeons to work faster in the surgery room. Planning time pre-surgery is also reduced by more than 90%. And this, thanks to AI, right? It used to be days. Now we reduce it to hours. And in some specific indications where our AI is fully trained, it went down from hours to minutes now. Complications also go down because, again, everything is fully customized to the patient. And with the porous structure, which is our own patent, right, called OsseoMatrix, we can achieve 60% better bone integration than compared to other standard implants. And this is, we publish the results in lots of peer-reviewed journals. And I would say the results that, these numbers are important, but I would say the results that make us smile every single time is when we see the post-op report or the emails from the surgeons sharing how well the patients are doing 6 months after the surgery. We see how the solutions help them a lot and how it changes their life, right? We have seen a lot of cases where, I I remember a patient who had diabetes and who was told that he might lose his leg. And after being treated with our implant and surgical planning system, he can now walk again. We also had a patient who had a tumor so large that half of his jaw needs to be removed. He worked at a hotel, right? So his appearance mattered. So we helped the surgeon plan his case so precisely that after the surgery, his left and right face are still perfectly symmetrical. So these results are what push us to go forward, and we use it as our gasoline to go faster every time.
Yeah, that's awesome. First of all, that's got to be very rewarding. But it also, I'm kind of wondering about surgical adoption, right? Because it's no doubt that surgeons are a little bit slow to adopt to new technologies as a rule for often good reasons. So I'm just kind of curious, how you're dealing with that challenge with the new technology, and how the clinicians are really responding to your technology, and what's driving that satisfaction rate that you're talking about. Can you provide us some additional insight there?
Yeah. So from our experience, the surgeons, they all love it once they try it, but get them to try it the first time is very difficult. So they and we understand them, right? Because all the surgeons are trained to perform the surgery in a certain way, and some of them have been doing it the exact same way for more than 20 years. So they kind of wait for someone who they respect in the field to try first and speak on our behalf. So that's why our strategy is always going to be to work with the key opinion leaders in the field and go to the conference with them and explain how our technology can help improve the outcome of the surgeries and also speed up at the same or even lower cost, right? But from our experience, again, once the surgeons try it, they will 100% see the value. There are two most obvious benefits that we normally hear the surgeons say, right? So one, everyone says that it saves them a lot of time and also reduces stress in the operation room. because no more freehand cutting, no more having to bend the fixation plates over and over. And two, they all say that the surgical outcomes are better. This not only makes us happy, it also makes the surgeons also very happy, right? So the healing is faster, the fit is perfect. And one side benefit is with 3D printing, right? They can also show the patients exactly what the surgery will look like, also ahead of time, which also help reduce the patient's stress and concern as well. Now, before we launch a new solution, right? And I think this is the reason why the surgeons like our solutions. Before we launch any new solution, we spend a lot of time listening to the surgeons. It's always a two-way process between our engineers and the surgeons to learn their needs, their concerns, and use what we know, engineering talent and knowledge, to help them making their work better, right? There's not a single product in our portfolio that we just make and hope that it will be adopted. We involve the surgeons in our network throughout the process. We co-design everything with them, from products to workflow. I think it's very similar to Formula One, right? So I'm using this example because I'm a Formula One fan. There's a large team of engineers and one driver, right? So if the engineers just make the car that they think is good without listening to the driver, most likely the team will not be doing well, right? So there's a science part to it, there's engineering part to it, but there's also an art part to it as well, which we never understand. Unless you are out there on the track in the racing situations, there's no way you understand the needs perfectly, right? So you have to listen to the driver. We are the same. So we are not the one who perform the surgeries. We have to listen to the surgeons. We are building the products and the solutions that serve them, not serve us. And that's what we always do, and we'll continue to do so. I would say that's the main reason why we have the 100% surgeon satisfaction rate.
Yeah, I love that listening part, right? Because so often that gets glossed over or not paid attention to. And I would think that not only has it helped you with some of the processes, but I'm thinking it's also led you to some rather novel designs and outcomes just from a product development standpoint, right? Is that what you're finding?
Yes, that's 100% correct. And that's these surgeons, they are also they're also very good researchers. And they're not just the one who perform the surgeries, right? They always have this idea of how to improve the surgery. And the more you listen to them, the more you get the ideas. And I think this is how we create all the differentiations when we have to launch these similar products compared to other big players in the market. These surgeons, even though they are not our employees, some of them are our advisor. But the more you listen to them, the more you get the ideas of how you can improve your work and your products, and that
Mhm.
builds a very good foundation for future success for all the startups.
Yeah, that's terrific. And Vicky, you touched on something too that I want to come back to. You talked about saving some surgical time and the saving OR time and recovery, which everybody knows globally healthcare systems are struggling financially, right? So maybe you can walk us through your approach in terms of how it streamlines, OR staffing, right? Because if you're going from 10-hour procedures to 5-hour procedures, that's a big one, right? Scheduling and even supply chain issues. Can you give us some insights in terms of how that's developing value and maybe cost savings for the hospitals in general from a business standpoint?
Yes, absolutely. So time in the operating room is very expensive. So when we reduce a 10-hour surgery to 5 hour, that means more patients can be treated, right? And less staff fatigue too, and better use of resources in general, right? So our solution not only do that, but it also reduces the need to stock different implant sizes. Everything is made to order and delivered in a week or less, right? So a standard non-custom made implants, normally the hospitals needs to stock a lot of variations in sizes and shapes just to perform one surgical case, right? Now with our solution, hospitals don't need to hold that excess inventory anymore. And because of our surgical planning platform is online, we can also serve the hospitals from anywhere, right? And this flexibility is a big plus for any healthcare system. We have also seen a lot of cases, especially in Asia, right, where the healthcare system is not as developed as the one in the US or in Europe. Now, over there, the surgeons in remote areas, they are not confident enough to perform major surgeries and choose to refer the patients to be treated at the major hospitals in big cities instead, right? It is not that they are bad surgeons, but they are not enough infrastructure and tools that allow them to perform the surgery safely and also efficiently, right? With our personalized surgical instruments, say cutting guide, for example, they can now do so on site without having to refer the patients to other big hospitals. And we have seen a lot of cases like this in Thailand already. So in a way, we are also helping to manage and also distribute the country's healthcare resources in that manner too.
Yeah, that's fascinating. And what struck me, I took a little note here was, if you can cut surgery time in half, I'm also thinking about time under anesthesia, right? Which is a big factor, especially for recovery and patient outcome. Have you looked at that particular statistic in what you're doing?
Yes, so it cuts the time for to the exact time required for the surgery, right? And not only that alone. So cutting surgery time can also reduce bone loss. And there's also a lot of data that confirms that the patient recovers much faster if they spend less time on the surgical bed. And in the cases we have performed in Thailand, right? In the cases that I shared earlier, where the patient have to do mandible reconstruction in the jaw, usually the patients will have to stay at the hospital to recover 4 to 5 days. But with the fixation plates, mandible reconstruction plates that are personalized, this recovery time can be shortened down by more than half. So that it also reduced the cost for the healthcare system in that manner too.
Yeah, and I'm also intrigued because in my research, I noticed that you've also seen a reduction in secondary surgeries. And I'm thinking, help me out, because a lot of times are those secondary surgeries being performed to get maybe a better fit or tweak the fit from the first surgery, and things maybe weren't quite settled right. And that second surgery was to make some adjustments or enhancements. But because of your technology, you can eliminate much of that. Am I heading down the right track with that?
Yes. So from our data, if you get the shape and size of the implants right the first time, and we can do that thanks to 3D planning and 3D printing, right? We can reduce the chance that the second surgery happening by more than 40%. But the sample size that we have are not large enough to make this a research article. But we see a clear demand of having a solutions that can eliminate the need for the second surgery completely, and we are exploring that with magnesium 3D printing, right? So from our research, more than 20% of the patients eventually have to go through a second surgery to remove the plates. This is not to adjust the plates because they do not fit, right? But in cases where you break a bone and you need fixation plates in titanium, if you use titanium, it cannot biodegrade, right? So you as a patient can have two options. Either you leave the titanium plates in your body for the rest of your life, which doesn't sound like a good idea, or you can go through a second surgery to remove the plates when after the bones are healed, right? So this second surgery alone can cost up to 30 to 40,000 US dollar or more in some cases, right? And that's not just money, right? It's pain, it's risks, it's hospital resources. And that's why we invented the bioresorbable magnesium alloy implants, which are also personalized by 3D printing technology. The benefits of magnesium alloy again, it can biodegrade in the body, so there's no need for removal surgeries. And we think this is a game changer, right? And also by cutting surgery time and reducing complications by using personalized implants, again, which is very precise. We also estimate that the hospital can save costs of around 17 to 30% per case, depending on complexity, right? And we have shown this in more than 200 cases already. So we are not just improving the outcomes, we are also reducing the total cost of the healthcare system as a whole.
Oh, that's phenomenal. And now, as I look, you've been very successful in Southeast Asia, Kind of curious about your strategy for expanding into the US marketplaces and maybe Europe. What type of partners are you looking for to help achieve that?
So yes, we are expanding to the US this year, and the US is a very interesting market, right? It's a large market share when it comes to medical devices. Now, for context, for the audience, statistics shows that more than 80% of the market share worldwide belongs here. It's also where top medical device companies are located, right? So it's a huge opportunity for us, for sure. But at the same time, it also means that the market will be very competitive. Now, the main value that differentiates us from other competitors is that we focus on both hardware and software. We don't just provide implants. We also provide surgical planning software and services, which are backed by AI, right? It's end-to-end surgical solutions, and the personalized implants is only one part of the entire value chain. The main strategy that we have is to build trust first. And this is through pilot programs with top hospitals and research centers. Now, we have done this successfully in Thailand, in other Southeast Asian countries, and also in a few countries in Europe, right? So we are looking for partners who share the vision and those who want to increase precision, to use AI to great effect, and to improve personalization in surgical care. We also want to work with payers and health systems that understand the value-based care. When we reduce the OR time and re-ops, we also help the entire system, not just the patient, right? We're also working with researchers at Johns Hopkins and other US institutions to prepare for this expansion. And we look for a commercialization partner. This could be in the form of companies or partners who are willing to distribute our products. And this will be throughout the workflow, meaning they will also have to understand our AI platform, which we are happy to give them training. And then we look to partner with a hospital chain or some states or hospital network in certain states that are willing to do a pilot with us. And we'll go all in on that.
Mm-hmm. Yeah, that's fantastic. So, Vic, you've provided some really great insights here. So, many of our listeners out there are early stage innovators or healthcare investors. I'm wondering what advice you might have for those looking to commercialize AI-based solutions into complex clinical environments like you're working with. Do you have any insights you can provide our gurus out there?
That's a very good question, Tom. Thank you. So my first piece of advice is to start by listening with a very open mind, right? Now, don't just sit in your lab and think you understand what's needed. If you are doing medical device, you should go to hospitals, talk to the doctors, talk to the patients if you can, and also observe surgeries if they allow you to, right? This will help you understand the pain points. And that's what we have done when we just started the company. And then start early, but start small. You have to prove the value in one or few use cases first. And that's your MVP, right? Use that MVP to build trust because, again, that's most important thing in all the MedTech segment. Now, second, it's easy to overhype AI these days. And what we should focus on instead are real outcomes. Make sure your product actually helps doctors and patients. You can use AI to speed up your workflow or cost down your solutions, right? But there has to be real tangible outcomes that comes with it. And you should be able to validate the value of the AI in your workflow. Now, also, you have to be patient in the process. The healthcare sector is lucrative, but at the same time, it's slow moving, but with a good reason, right? People's lives are at stake here. So you're not just making products, you are creating tools that could save life, right? That requires big responsibility. Don't rush. Instead, focusing on providing something that's not only innovative, but also safe, tested, and also reliable. And finally, probably the most important recommendation is to build a great team around you. This journey in the medical device industry is not the one that anyone can take alone. Now, we have been very fortunate at OsseoLabs to have a team that specialize in certain things, which are all different. And we challenge each other every day to push the limit of what's possible. We also have a group of advisors who provide the kind of mentorship that sharpens our focus. They know something that if we need to learn, we have to spend more than 10 years to do so. So anyone competing in this segment, doing startups in this segment, can learn a lot from talking to as many advisors as you can, learn as much as you can from them. And finally, perhaps stay humble, stay curious at all time, and work very hard towards your goal. I like to say to my team all the time, work 18 hours a day and you'll get there before you know it.
I love that. That's a great overview. So, Vicky, first of all, I'd like to acknowledge you and thank you for your time to be our guru today. If somebody wants to learn more about OsseoLabs or connect with you, what's the best way to get in touch? Are you on LinkedIn? Is there a website? How do we learn more?
Yeah, so we have a website. It's worldwideweb.osseolabs.com. And our LinkedIn is under the same company name. So worldwideweb.linkedin.com/company/OsseoLabs. And look forward to getting in touch.
Oh, that's fantastic. So once again, Vicky, thank you so much for all the insights that you provided us today. We really appreciate your thoughts.
Thank you, Tom. Happy to be here.
Thank you. Thank you for listening to MedTech Gurus. I am Sylvester Harris, your MC. If you want to learn more about Tom and his consulting services, you can go to www.pctmedical.com or email Tom at tom@pctmedical.com. Now, I can be reached at Sylvester Harris, that's SylvesterHarris 5048@gmail.com, and I'd be pleased to discuss any voiceover work that you may want for your company or broadcast. Hey, thanks so much for listening, and catch us on the next episode of MedTech Gurus.